Hello everyone, good morning. Today we're going to discuss about real-time streaming insurance analytics, which is like real-time processing. So in this whole process, if you see in the diagram, we have added many components like Confluent Kafka, Databricks, like producing from the Python producer. So before we discuss this end-to-end, first we'll go piece by piece. First we'll discuss about like Kafka, what is Kafka and how we can configure Kafka in Confluent Cloud, how the easiest way. So how to optimize the process of ingesting the data from the source to target. And once the data in Azure Databricks, what is the architecture we are using actually in this Databricks? It's not something like we are ingesting and loading, but we're following the architecture, like different types of discussion about like Medallion architecture. What about the singleplex or multiplex architectures? So we're going to more in-depth, deep and dive into this session. So let's go step by step and discuss the topic wise. So first, let's start about Kafka. That's actually the ingestion, the source thing, right? Let's start about the Kafka thing. So on the Kafka side, let's discuss about like the introduction part, about like what is Kafka and why, what are the advantages, how we can configure the Kafka. There are multiple ways we can configure the Kafka. First, coming to the Kafka. So Kafka is actually open source platform. It is a open source platform. It's the open source event streaming platform. You can call streaming platform. So which is nothing but it is going to handle the real-time data feeds. So this is actually developed by the LinkedIn originally, and later it is donated to the Apache Foundation. So what are the main thing advantage of the Kafka is it can send very high throughput, like millions of records. It is going to send within a seconds. So and the fault tolerance, like we have replications and everything. We have a multiple broker systems. We're going to discuss about like what are the components and features. So, and the main concept here is it is going distributed messaging system. So, what are the key features of Kafka? The key features of Kafka is the first thing is it is publish, subscribe messaging system. So, what is this? This is nothing but we have a Kafka here, and let's say we have a producers is going to produce the data. For example, let me take let's say suppose I'm taking Python producer. We have many producers, many sources we can integrate actually. So on this Python producer is actually producing the data to the Kafka. And next, what we are doing to? So here we're going to load the data into the topics. So what is the meaning of topic? The topic is like a table, nothing but. So we're producing into the topic. So like we have many producers and many topics is going to produce it. So suppose if I take this Kafka cluster, when you say it's a cluster, we have a topic. So we have a topic one. For example, let's say I have a customer data. We have a topic two. For example, we have policy data, and we have topic three. So we have something like a claims data. Suppose I'm just talking about the insurance domain, but if you take any domain, there are different internal data, right? So payments data, something like this. And we have many producers. I'm just taking an example as a Python, but let's say we have many producers. So the many producers are producing the data to the Kafka topics. And here, like we are doing the publishing, like we are sending the data to the Kafka topics. And we have a consumers. So these are all like the producers, right? Producers. Who is going to consume the data? So they are the consumers. So the consumers are going to consume the data. So we have, let's say, consumer one. So we have a consumer two. We have consumer 3, we have a consumer 4. So the consumer is going to subscribe from the topic and then they're consuming the data. It's just something like YouTube, guys, YouTube, like we are all subscribing, right? Like whenever someone upload the video or something, so immediately you're getting the video, right? Same way, simple mechanism. So the producers are producing the data and the consumers are consuming the data. Simple. That's what we call publish, subscribe, messaging platform. So here producers publishing the messages to the topics and consumers are subscribing to these topics to get the data. So that's one of the best feature of these Kafka systems. And the next one is about the scalability. So what is this scalability here? See, Kafka can handle the large volumes of data. It will follow a broker system. We can add a number of brokers like clusters, and then we can handle large volume of data. And then the next one is the durability. What is the meaning of durability? So which is nothing but, so all the messages, whatever you are sending to the Kafka, and the same way it consuming what we have in the topics. This topic I said like a table, right? So it can persist the data on the disks and it is going to replicate across the multiple nodes in a cluster. And if you see the beauty of this messaging platform, whenever the producer is producing the data, immediately it will go to a topic and it will consume immediately. So which is like, I think about real-time processing, right? So it's a real-time processing. And as I said, the producers and the consumers, we have hundreds of producers, hundreds of consumers are available in the market. So it means the integration. This is a very important topic. The integrations are very important here, like how you're integrating your producers. Like for example, let's say I have a SQL server, okay, I have a Oracle, okay, or we have different systems like I have APIs, or I have IoT systems. So how to integrate all these systems as a producer? The same way, how I can consume the data. For example, I have a Snowflake. Let's say I have an Elasticsearch. Let's say something like I have a suppose SQL server, anything, or some I have APIs or some machine learning platforms, anything. So how these integrations works well between these producers and consumers. So this Kafka system, it is going to easily integrate with the both sides. So before going to more in depth on this, first let's see what are the core components. What are the core components of this Kafka platform? So what are the core components? As we discussed, first one is the producers. Producers is always producing the data. So what are the applications we integrate that is going to publish your data, and the publishing data is actually going to your topics, all these topics, right? So we will define the dedicated topic for each source systems, each source files or tables, whatever it is from the source. So for example, in the source, I have a payments table. It will go payments topic. In the source, something like I have a policy table. It will go a policy table. Something like in the source, I have some CRM data or customer data, something I have like the customer's data. So the producers are going to produce the data. That's the one of the core component. And who is next? So nothing. Next one is the consumer, right? Consumers. Consumers are nothing but consumers are going to consume the data here. Consumes the data here. All these consumers. So we have a number of consumers, guys. We have a number of producers and number of consumers. So Kafka system is going to give a flexibility that you can easily integrate, produce your data, and if you have requirement about transformations, you can transform the data, and then you can consume it as well. So that's one of the core component. And the next one is partitions. Partitions are very important. Why partitions? See, if I take a topic, in the topic, we have multiple partitions. Why? It is to distribute as a parallel processing. For example, I have partition 0, 1, 2. So when the data is distributing, so the data will distribute to the partitions. And the same way, the consumer is going to consume data from the partitions. So what is the advantage here? We can do the parallel processing. It is not something like it's going on only one way. We have a river of the data, and we have a number of pipelines are created. The water is distributing to the multiple pipelines to reach to the destination. The same way here, we have a number of partitions. You're producing the data to number of partitions, and the data is dividing internally, distributing and producing. So the topic contains multiple partitions. Starts from the 0, you can increase. Next one is the important one is the brokers. So brokers are nothing but like servers. It is going to manage of all your Kafka data to handle requests. Brokers are like clusters. So it can handle your data. It can manage your clusters and everything internally. And the next one is the zookeeper system. So zookeeper is going to manage all your metadata, and it is going to lead the election of Kafka. So basically, this is now in the new versions, we're going to use as a craft system. So which is nothing but this is advanced system than zookeeper. So from so many years we're using a zookeeper, now we're getting a new advanced system called craft. So this is about the Kafka, the core components, guys. So we'll discuss more in depth and more things on the Kafka in the next sessions as well. So on this is a high level. Okay, now then if you see in the market, everybody is talking about Confluent Cloud Kafka, Confluent Cloud Kafka. What is that? What is the difference between the Apache Kafka and Confluent Cloud Kafka? It's nothing but like ice cream and vanilla ice cream. So which is nothing but the Confluent is a commercial platform. Confluent is the commercial platform. So this is a commercial platform for Apache Kafka. So it is developed by the original creators of the Kafka. But the good thing is it is going to extend the Kafka capabilities and provide the enterprise features. It is going to provide enterprise features. Like is nothing but what it will do? It will nothing but it is going to manage your cloud services, and if there is any additional services like toolings, anything, so it's going to provide it. So what are the key features of this Confluent Cloud? So the Confluent Cloud, the key features are, one of this is the Confluent Cloud. It is going to fully managed. It is going to fully managed Kafka as service for all the clouds, means like AWS or Google Cloud, GCP or Azure platforms. It's going to provide everything. And it is going to provide a schema registry. This is a very important topic coming to the schema thing. What is a schema registry? See, there has to be a consistency schema when producing the data and consuming the data. It is not something like I'm producing ABC and it's not something like you're receiving the CDE. The schema has to be consistent on the both producing and consuming. Then the flow will be good. So the schema registry will ensure that the data consistency across the producers and the consumers by enforcing that the formats. What are the formats? Like Avro format, JSON format, or protobuf schemas. It is going to provide the support with all these schemas. And the next, the key feature of the Confluent Cloud is the case equal to B. So what is this? See, Kafka is not only designed for the streaming platform. Of course, it's a streaming platform, but what I'm saying is not only for producing and receiving. So we can do transformations as well. So once the data is landed into the topic, now my client is asking, oh, okay, I want to do some transformations. Okay, let's apply transformations. Okay, I want to filter the data. I don't want all the data. Now my client requirement is, okay, I want to filter the data like where the customers are only the last year, only the timestamp, something like timestamp is less than 1 year, for example. Or something like a policy, okay, I want only the policies like who only from the last 2 years of policies. Or the claims, like I just want to see last 6 months of the claims and payments. Okay, I want to see who claimed more than 100K, something like this. Yes, you can filter it out. So you can apply these transformations. So what is the way you can apply? The best and the easy way is I can say KSQL DB is same like a SQL, guys. So you can easy to transform the data. So nothing but this is SQL based streaming processing engine. And the important thing is this is a real-time data transformation. And until now, we discussed about within the cluster, within the brokers, all the topics and transformations and everything. But coming to the producing and consuming, how to integrate? Do we have any best mechanism to integrate this? Yes, that is called the connectors. Kafka connectors. Confluent is providing a lot of connectors. All the connectors are pre-built Kafka connectors for databases like SQL, Oracle, Teradata, DB2, anything. Take any name of database. We have a dedicated connector for that. And the cloud storages, what is meaning of this? Like this is nothing but if you have AWS, we have S3, and we have a Google Cloud Storage, and Azure, we have ADLS. So all the cloud storages also, they have a dedicated connectors. And if they have something like analytical tools, connectors also available. So this is a friendly system, guys, where we can integrate easily with using the connectors, store the data, and process using KSQL DB, store your schema on the schema registry, and integrate easily with the multi-cloud systems. And we can process all your real-time streaming analytics. But what about like how we can do the governance? If you want to do the security and governance, yes, we can do it. It will follow a RBAC policies. What is RBAC? It includes like a role-based access control. Role-based access control systems, and we can monitoring is also available here. Auditing, monitoring, everything is like all these tools are pre-built we have. Okay, and what if I have a data in the multiple data centers or multiple clusters? So there is a new advanced feature is called the replicator and the cluster linking. So what is this? This is nothing but it is going to enable your cross data center applications. Enable cross data center replications of all your Kafka topics. What it means? It means, for example, the same platform I have. For example, I have another cluster in the different. I have a different cluster. Okay, now my client requirement is they want to replicate the data. They want to replicate or they want to produce the cluster linking. Like nothing but like here two things: replicating, mirroring. So if you want to replicate something like you can replicate like this. You can do the cluster linking here. So this is the one cluster, and this is second cluster. We're linking the two clusters, these two topics. Like this, you can do it easily, guys. So it means here the concept is it is going to enable. This is called the cross data center. So it means it doesn't matter where is your cluster. You can easily integrate all the clusters easily, and you can extract your data wherever it is from. So this replication and the mirroring concepts are very important in the Confluent Cloud features. So, as I said in the connectors, we have around 120 plus connectors are available in the market for the Confluent Cloud integrations with this. So these are all the core features, guys. Why we need to use this Confluent Cloud is because if you want to avoid the managing the Kafka infrastructures, it is going to provide a fully managed Kafka service. And as I said, it provides enterprise-grade security, governance. We have a pre-built connectors like Databricks, S3, Snowflake, MongoDB, easy interact. So we can easily to process your data. So as we discussed in the first diagram, on today we're going to discuss about the project. In this project, if you see, we are producing a data on the Confluent Cloud Kafka. So this is we are using here for ingest your data, streaming your data into Databricks platform. What we do here the analytics and the AML, everything here. Okay, so this is a basic core components of the Kafka platform. So now let's see how we can. Let's see the first part of the job today is we're going to create all these topics and we're going to produce the some data today. First part into the Confluent Cloud. Before that, first let's see how we can create a Confluent Cloud cluster, how we can configure it. So Confluent Cloud cluster is if we just log in the Confluent Cloud login, we can go to the portal. It's a Confluent Cloud. So it is going to ask you the sign in. You can sign up and try it for free. So when you're doing first time, guys, so it's a $400 is free for the first 30 days, and you can sign up with any platform. So when you can just do it as a sign up, it will automatically enable your cluster to open. You can choose by login by any platforms like Azure or Google Cloud or AWS. Means if you're already available in the AWS, for example, let me show you my Azure account, Azure login. So in the Azure login, every cloud have their own marketplace. So you can just go to the marketplace and then you can access whatever the integration you want. It is not something like we need to go always to the tool. You can go with the cloud. In the cloud, if they have available plugin, you can just use it. Okay, I'm just signing Azure Cloud. And in the Azure Cloud, if you see, creates a resource, Confluent. Confluent, see, it is available here as a SaaS product. What is a SaaS? Software as service, which is nothing but it has everything. All the recipe is already ready. You just open and play it. So if you go to this, we just do the subscribe, and it's going to ask you to create this resource group, so subscription, and I'm going to create a new subscription, for example, Confluent Cloud Resource Group and two. Okay, and the region. Just select your nearest region and link the see if you're doing the first time, if you don't have any cloud account, you can just do here directly create a new organization. That's fine. That's good. If you have already a Confluent Cloud account, you want to integrate that account to your Azure building here, you can just link it. So when you go to link an existing Confluent Cloud organization, it is going to search based on my login. Let me log into my account. Okay, that's good. So now I just log in my original account and is asking, okay, this is the Confluent updates. Yes. Go ahead. That's good. So this is a pay-as-you-go system. So if you use, it'll charge. Review and create. It is reviewing. Yes, success. So it is creating the platform. So this is the way you can do it. So deployment is in progress. So it means the Confluent Cloud will create, and from here you can go to your Confluent. Or the other way is, as I said, you can just go to Confluent login. If you don't have Azure account, if you want to go directly your own Confluent Cloud account, that's fine. You can go to Confluent Cloud login, and here I have already logged in, so I just got like this. So as I said, I showed previously, you can sign out. It will ask you first to sign up, and Remember, you can claim the $400 30 days. You'll get by default anyway. Just enter your details and sign up. You'll get it. So if you have an account already, you can log in. Let me log into my account. Once you log into your account, so this is the cloud platform, guys, Confluent cloud platform. So in my previous session, I have presented a video for how to install Kafka in Docker. If you want to play in your local Docker system, you can play. But I recommend you, if you are planning for the multi integrations, multiple producers, consumers integrations, I recommend you use Confluent Cloud. Anyway, it's giving $400 free. You can use it to practice, do the hands-on for your POCs and projects and things. Okay, coming to the environments, I just created one default environment. This is one cluster. If you want to add more, you can add more the environments. It depends upon like what type of environments. If it's a dev production, so the environments you can. So by default, they'll give you one cluster. You can just use it. You can just create it when we start the system. So if you go to the cluster, you can see all the things here. What is the cluster? So this is the cluster, and go to the topics page. These are all the topics I have already in my mission. Okay, so and the KSQL DB, if you want to query something, you can query here. And the connectors, as I said, we have 120, more than 120 source and consumer connectors, producer and consumer connectors. If you take a Snowflake sync connector, Snowflake source connector, S3 source connector, S3 sync connector, you can just search it, just it's Snowflake sync connector, and the same way, for example, S3 source, S3 sync, Databricks connectors, HDFS connectors, Hadoop distributed file systems, everything. Elasticsearch connector, everything. You just plug in and then use it connector. Okay. Now I'm going to create the topics. Okay, so let me go and create the topics first. I'll just show you how to create topics. So topic 1, for example, I'm taking the policy details version 1. I have already the name is there, so I'm just taking as a version 1. So create a topic like this. I've just created a topic. See, if you go messages, I don't have any messages. That's fine, because we have not produced that. We'll produce once we create the topics. Okay, now check policy details version 1 is ready. Let me delete. I have the existing topics. This is the way you can delete. See, it is deleted. Suppose I'm just going to delete. I'm just deleting the existing ones. It's the payments, right? This is deleted. Last. Okay, so I have one topic is ready. I'll go with the next topic, because see, now I'm going to produce the data to all the topics. Just a random data, guys. So we'll see. I'll explain you. Customers -v1. Taking only one, as I said, how many partitions you want. So default is taking 6, but 1 is enough. If you don't have much data, if you're producing a small data, you don't need to waste the resources. So suppose I'm just taking the claims, one partition, keep, and next one is, suppose I'm taking the payments, one partition. Okay, nice. So I just get the 4 topics. That's good. If you see a topic every time, you see the overview about like how many produced, production, consumption. You see all the list of messages. Still now we have not produced any message, but you will see messages once I produced. Data contracts. I said here the schema registry, where you have the schema is going to add, produce value key schema. And configuration, here you can see what is your topic name, how many partitions you created, what is the cleanup policy. This is very important, guys. See, topic Kafka is not designed something you persist your data continuously. This is a streaming platform. It's coming and going. That's it. If you want to store, yeah, you can store. It's not a problem, but this is not designed. So by default, the attention period is 1 week. Means whenever data is entered into the topic, it is stored only 1 week, and then you lose it. If you want to increase, yes, you can increase. If you want to decrease, yes, you can decrease. It totally depends upon what is your project requirement. If you have something like a reference data, so okay, the data is static. We want to use something for joins. Yeah, you can just put the compact mode, which is like store permanently. But it is not designed to store the huge data permanently. It is only designed just coming and going. And the message byte systems and everything, yeah, you can see the full configurations. So in the real-time projects, how we will use it, like we're going to configure all these based on our requirements. We can change all these and we will deploy into the production environments. Okay, we got the 4 topics are ready. I have a requirement now is let's see the first part of this project now. What is that? Let's discuss about this first. So here you see Python, but see, it doesn't matter, guys, the producer. I'm just producing the Python because I can produce some fake data. I don't want to call that bad word fake. I can call the synthetic data. So it's a new keyword in the market, synthetic data. So since the synthetic data is going to produce the data, it depends upon your domain. It is going to provide synthetic data. You can load your data into your topics. Okay, now I have 4 topics. Now I want to produce the data into the topics. See, as I said before, you can use 120 plus connectors are available in the market. You can just use any connector to produce the data. I can explain you some of the connectors in the future sessions. For now, simply we'll go with the Python producer. That's a ready-made code I have already available. I would like to quickly show you how we can configure. This is my local system. See, this is a beautiful integration. My Python is in my local system. My producer is on premises. On premises means it's in my local on premise system. But what I'm doing, I'm going to produce the data to the cloud. How to integrate, how to securely connect this case. If you go to the Confluent cloud, if you go to your cluster, you will see called API keys. Now, what is this API key? Say you can create your key securely. So it is asking, do you want something like a service account for a production purpose, connecting multiple users, something? You go this way. No, this is something like you are only using for your loading your data or something. You can use it. Recommended for development, recommended for production. Go for development first. Click the next. So this is going to provide a key and secret. You can use wherever you want to produce your data. Okay, so the description, I'll say produce Python source synthetic data. So let me just copy first. It will download anyway, but let me copy. Actually, you can copy directly. So it is key, right? So see the Kafka API key. You can just copy here. Good. And the secret, copy here. Kafka API secret key. Perfect. Download and continue. It's fine. The API is created. So what you're going to do, I'm setting up a new client. I'm integrating my APIs. Perfect. Okay, perfect. I have something. This one, I'll delete this API. You can delete it. Perfect. So this is the key just now we created and for producing the Python synthetic data. Super. Okay, now, okay, this is the code. I'll share the code to the GitHub. You can just play it. So what are the topics? I have claims, customers, V1, and policy details, for V1, and payments. See, I'm not producing into one topic. I'm producing into multiple topics. This is a very important concept. I'm producing for multiple topics from the same Python code. It's just like I'm just producing the synthetic data. Just use a faker application package. It can send. Okay. Do we have any messages? I don't have any production consumption. It's all empty, right? It's 0. Okay, now what it's saying? Okay, so this is going to generate the policy data, the claims data, something customer data, generating the payments. Is going to generate all your data, produce all the messages to Kafka. Okay. So it is going to take the topics and based on the function, it is going to produce the data. So into these topics. Okay. So now I'm going to produce my data. Okay, starting to produce the data, the policy details, and then claims, customers. Okay, what is saying? Authentication failed. I know why it's failed. It's because you need to give the access to the topics. And okay, it's because the topic names. Policy, did I use somewhere the topic names within the functions? Yeah, here. While using data generators, let me use this one. It is policy details. Okay. Claims. Okay. Anything else? Customers, icon viewer. Okay. Payment. Perfect. I'm just going to break this. Just do the control X. See. Just breaking this. I'm producing now again. So see now it is producing. Sending to the policy data, sending to claim, sending to customer payments. Let's check. Go to first claims, messages. See, we have received a message. We have received a message. We can see the claim ID, policy ID, claim amount, status, pending, everything. If I go with the customers, let's go check. So it is on the way. Saying something unknown topic. What is unknown topic here? Let's take the other topic. Payments. See, we got the payments. I think another unknown topic is this is policy hyphen details. Oh, sorry, it's hyphen, right? It's my mistake. That's why it's saying unknown topic. Topic has to, the topic names has to match on the both sides. On the producer side and the consumer side, it has to match. Okay, see now I got the data. I got the policy data and payments. I got the payments data, super. And customers, what happened to customer? I think it's customers. Oh, again, here I did the mistake. The customers, not customers. It is customer V1. Customer V1. Uh, okay. Let's load again. Now it will go everything. See, it is producing every second. See, now you'll get everywhere. So we see we got to. You to stop, or else you'll get continuously millions of records with this fake, with this synthetic data. Let's stop it, or else you'll get more billing. Okay, I just stopped it. I just control C, it'll break. Okay, or else it'll produce all the random data. See, there's no big logic in this. It just produce random data. That's it. Based on the schema, what we define, it's going to produce random data. That's it. Is not something a miracle. It is something producing the random data by the random generators. That's it. Okay, so if you see now, we got the 4 topics are created and 4 producers are producing the data. So this is what we discussed till now. So we used on-prem. See, the beauty here is like connecting the API keys very easily. It's very difficult to integrate systems, right? Normally in the real-time system, very complicated. But the easy way is the API keys, security keys is easy way to integrate. So we used the on-prem local Python producer, produce the data to the multiple topics. In the next session, we're going to see the integration of the Databricks and what is Databricks, how can integrate from Kafka to Databricks, and how create the layers, what is a Medallion architecture, singleplex architecture, multiplex architecture. We'll see a lot of things, guys. So what I request you is please go through this. And if you have any questions, you can just raise the questions. Um, you can send an email to the AccentFuture. We are very happy to support you anytime if you have any technical queries. We are not doing something. We are doing for with a passion. Thank you.